Okay, I got angles here. I got a resultant force acting in the positive x direction of 500. So my resultant force is right here. Fr equals 500, right along the x-axis there. It wants me to find the determinant magnitude of the coordinate direction angles of F2 right there. Okay, I also have this other force F1, which I have drawn right there, and we'll start with that one and we'll write that force in Cartesian form. So F1, I need the x, y, and z components of this. So what we're going to do here is I'm going to actually switch colors, make it a little easier to see here. Okay, and I'm going to break this up into two triangles. I'm going to have this triangle right here, where this is a right angle right there in that vertical sense right there. And then I'll have another triangle, and we'll draw it green, okay, which will be this triangle right here, like so, where over here is your right triangle. So that's lying in that XY plane. Okay. Now, what I'm actually looking for here is Fy is right here, Fx is right here, and then Fz is actually that red value, which is, whoops, which is right here. Okay. And I guess I have this side right here. This side of that triangle is what I know, which is 180, right? And what I have kind of along that middle there, I'm just going to call, well, I'll just call it F for this point. And that is the one leg of the triangle and the red triangle and the hypotenuse of the green triangle. Okay? So the first thing I do is I recognize FZ is just going to be opposite of that 180. So this is going to be 180 sine of 15, which is pretty straightforward, right? And that means this F here is going to be cosine. So that's going to be 180 cosine of 15. Now that's the hypotenuse of that green triangle, right? It's also the adjacent leg of the red triangle. Okay, so I'm going to switch my color back to green here. Okay, and now knowing that that's the hypotenuse, fx is opposite of 60. Okay, so I take the hypotenuse times the sine of 60, where the hypotenuse is 180 cosine of 15 times the sine of 60. Again, I take that hypotenuse times sine of 60. Fy will be that hypotenuse times the cosine of 60, where the hypotenuse again is 180 cosine 15 times the cosine of 60. Okay? So from that, knowing those values, I can come up and write my force F1 in Cartesian form, right? So 180 cosine of 150. This is I'll just write them right here. This is 151. Okay. This is 86.9. Okay. And the z component is 46.6. So writing that in Cartesian form, I get 151i plus 86.9 j minus, because FZ is pointing down, the other two are in the positive direction, minus 46.6K. Now, F2 is what I'm looking for. I don't know anything about it. So I say F2xi plus F2yj plus F2zk. Those are the three values that I'm going to try to solve for. Okay. I know my resultant force is given in the problem statement. It's in the positive x direction. It's just very simply 500 in the x direction, like so. So now I just add up my x's, y's, and z's and set them equal to that resultant force. Okay, so what I get is 151 plus F2x equals 500. And then I get 86.9 plus F2y equals 0. And then I get negative 46.6 plus F2z equals 0. From that, I solve for my x, y, and z component for F2, which is what I'm looking for. And when I do that solving, I get 349 in the I, negative 86.9 in the j, and 46.6 in the k. And again, if the problem didn't ask me, I would stop right here, call that newtons, box it in. But of course, the problem is asking for the magnitude and coordinate direction angles. Well, the magnitude is easy. That's just square root of the sum of the squares. So 349 squared plus 86.9 squared plus 46.6 squared equals, and that equals 363.9. So that's the magnitude of this problem. And then again, alpha, beta, gamma is just the inverse cosine of the x, y, and z components over that magnitude. So that'll be the inverse cosine of 349 divided by that 363, which is 15.8 degrees. This will be cosine of the y component, which will be negative 86.9 all over 363 equals 104 degrees. And this will be the cosine of the z component, which is the 46.6, divided by the magnitude, which is 363. That becomes 82.6 degrees. So again, either way is okay. It depends on what the problem's asking for. I'm a bigger fan of the Cartesian coordinates. I think I could draw that resultant, or I guess this isn't a resultant vector, but I could draw that vector more easily than given the resultant force in those coordinate direction angles.